Hello, my name is Evelyn, and I'm from the University of Texas Rio Grande Valley, and I will be presenting on the semi-automated analysis of citations over a century of precipitation literature. Special thanks to my mentors, Dr. Hackenberg and Dr. Richards, and to my sponsors, Texas A&M Material Science and Engineering OREU program, and the Los National Laboratory. Additional thanks to Dr. Jessica Lopez. So, case study, the century of precipitation literature. What is precipitation? It's a heat treatment process that increases the strength and hardness of alloys. How does it work? Precipitates form within a matrix and act as obstacles to plastic deformation, which is caused by dislocation motion. And here are two examples of dislocation precipitate interaction. The first is cutting, where the dislocation has enough stress that it slices through the precipitate. And the second is looping, when there isn't enough stress, so the dislocation just wraps around the precipitate. And this wrapping around this new loop is an obstacle for further dislocation. And then over here, we have the three main steps for precipitation hardening. The first is solution treatment, where the added material is combined with the existing material at very high heat. Afterwards, this new combination is quenched in water or oil so that the added material doesn't escape. And then it undergoes aging, which is heating at a low temperature so that the added material can disperse. And some materials used for high-performance alloys are aluminum, iron steel, nickel, and titanium. So, review articles and monographs help us digest an abundance of literature. Well, first off, review articles and monographs are papers that digest research that's already been done. So here's an example. This overview article is this subtitle of the overview article is an indicator that this is a review article. And normally citations are just something of an afterthought for most people. It's something you put at the end of a presentation, but they hold power because they can convey which authors, journals, and studies are trusted by professionals. Some citations are prominent while others die out from lack of being referenced. And this falls within the realm of scientometrics, which is the study of the quantitative aspects of science, scientific communication, literature, and research. Project is also related to bibliometrics, which is the quantitative method of citation and content analysis for scholarly journals, books, and researchers. It's also related to materials informatics, which employs techniques and tools from data and computer science to materials science and engineering. It also accelerates material, product, and manufacturing innovations. But for this project, the focus is not on manufacturing innovations, but on the literature of materials, not material-specific problems. And this is a diagram that shows that there's more depth and meaning to the components of a reference, like the author name. So the goals and questions. The goals of this project are to analyze the references of review articles, to create a map of the scientific structure of this field. Answer questions like, what authors are most frequently cited? How far do their references look back? Are there foundational papers? These questions can help us discover the historical significance, the schools of thought, and the trends that are all wrapped up in this. This is going to be conducted through this workflow with three main phases: gathering 20 review articles from the 1920s to the 2020s, which were screened down and selected for further processing. Phase 2, which is parsing Dr. Lopez's reference mapping for the desired information, in this case, author name and publication year. Now, Dr. Lopez's reference mapping is this large Excel file with all the references and review articles, and I parse them with Python. And phase 3, which is creating and analyzing graphs for author frequency, a look back window / relative age. This graph is looking at the age of the references that the author of the review article uses. So how far do they look back? Are they looking all the way to the 1800s or only, to the 2000s? And also to identify highly cited articles. So here's the first author frequency. I only took the first authors, not the second or the third, and journal, volume, and page number were not considered. Now here's a closer look at about the first 20 highly cited authors, the first 3 being Gainer, Gaylor, and Geisler. And here we have the most cited papers. Here they are, and you can see the raw reference and the sanitized reference. One of the issues of this project was that the older documents, called heritage papers, screening and down selecting them and having them go through optical character recognition wasn't enough for it to pick up the original text. There were lots of issues. It couldn't read it properly, so you have like dots, periods, extra numbers here. That was one of the issues. And I also highlighted the connections with certain authors that can hopefully shed light on the schools of thought. So you see here C.S. Barrett and R.F. Mell show up for some of these articles. And it turns out that R.F. Mell was a teacher and advisor to C.S. Barrett, Guy, and Geisler. Gaylor and Preston also shared a mentor. They worked under a man named Rosenstein in the United Kingdom. Gaylor is also the only woman on this chart, which is pretty interesting. So here are the look back windows. I made these graphs for all the review articles, but I chose 3 to share with you today. And the first is 1940 Bates. So you see here on the x-axis, we have the year of the published references and the number of references. And then here it's the ages of published references, with the average age being an orange bar. So some of the factors that affected the number of references, the number of papers published, was the discovery of age hardening in 1906, and the use of X-ray diffraction applied to materials problems, and precipitation becoming the basis of age hardening, which was discovered by men in America. The second paper is 1951 Geisler. So what affected the number of references and publications here was the early aerospace age, which saw a desire of increasing speed and maneuverability, and the invention of stress skin construction, which was when the outer layer of a plane was made and designed so that it could hold loads, so you wouldn't have to rely on the heavy structures within the plane. This required, a lot of material science. More invention was also encouraged by the need, or the government's need, for fighters and bombers in World War II. As you see with the previous graph, the average age of these references is within 20 years. And the last graph is 1979 Gust. The factors that affected this paper's references was the Cold War, which required aerospace advancements. Now, at this time, it was seen that a lack of understanding of materials, and therefore, a lack of understanding of precipitation hardening or improper employment of precipitation hardening, was a strategic shortcoming. Government needed and relied on scientific invention. So the Advanced Research Project, created, a part of the Department of Defense, created interdisciplinary research laboratories at various universities. There was also the energy crisis of the 1970s, and also that was during the time of the creation of the Department of Energy. So here's a summary for all the look-back windows, and the median age and the average age are within 20 years. They're about 13 to 14 years actually, with some process improvements. So initially the goal was to create an entirely new reference mapping, but that's inefficient, and I think it would have been better just to start with the reference mapping that already exists, and to prove upon it would be much more time efficient. Additionally, there were other avenues explored, one of them being using the document identifiers, the DOIs, which are online and are easier to work with and analyze, but there are many paywalls that made it difficult to do so. There's also some challenges with limitations with the heritage documents and their typos. In the future, I think it would benefit this project to look at the frequency of co-authors and last authors, to look more into the journal frequencies, and to analyze references of the references. And what I mean by this is looking at all the references that are here, looking at their references to understand what the foundational papers really are. It's very helpful, and it's a good starting point to look at the most cited papers, but I think it would be better to gather more evidence and to be able to determine what the foundational papers really are. Summary of results. The look-back window is about 10 to 14 years. Publishing and scientific discoveries affected by international events. Grenier, who's from France, and Gaylor from the United Kingdom are the most cited authors, and the most cited works were written by Geisler and Guy in 1943 and 1948, respectively. Both C.S. Barrett and R.F. Mill were co-authors to the two most cited papers, and R.F. Mill and his students at the Carnegie Institute of Technology, now CMU, were highly influential. And here's a picture of him. Here's my bibliography. Here is a snippet of the reference mapping, some code, and some sketches. Thank you for listening.